A whole plethora of a bunch of information. Okay, just a bunch of information given to you. And rather than you having to write down all these definitions, I basically provided everything for you. We're just going to add a little additional notes here and there. And then we're going to create a master cheat sheet that basically, if I look at it, I know what each thing is. So the first thing we need to know what a circle is. Who knows what a circle is? Who's drawn a circle in their life? Good job, good job. All of you. Matthew hasn't, but everyone else has. No, it's too late now. All right, we're going to give it more of a geometric definition. That is the set of all points that are equidistant from a given point called the center of a circle. So that's what creates a circle. I'm just listing all of those points that are the same distance away from that circle. So if you picture your compass and you open it up to a certain size and you spin it, all of those points are equal distance from that center. So if I take a compass and do this, every point is the same distance away. Bless you. All right. So a circle with center P is called circle P. So realistically, I don't want to put any more words in here, but this is actually circle P. You'd actually have a P right here. All right, I don't have room because it's going to cover up a whole bunch of words, but normally there would be a P there to denote that we have circle P. It can also be written as this little circle with a dot in it and P. Outside of geometry, we usually don't use that notation that much. We usually just say circle P, circle L. But because we're writing circle a lot, it might be nice just to be able to put a circle and a dot and say P versus writing that word over and over and over. The first new word that you might know is chord. A chord of a circle is a segment with endpoints on the circle. That means it has two endpoints. It starts on the circle and it ends somewhere else on the circle. So the example of that is this guy right here is a chord because it starts on the circle and it ends on the circle. So we have 2 points on the circle, which makes it a chord. Is this a chord?
Yes.
Does it meet the definition? Does it start on the circle and end somewhere else on the circle? Yeah, that is a chord. What I want to put on here, because I don't know why, but a lot of times we tend to mess this up. So I'm going to first start off by drawing. Do we agree that's a chord?
Yeah.
So that right there is a chord. That right there is a chord. It meets the definition. All right, here's the thing that trips students up. I will sometimes say, how many chords are on there? And a lot of responses I'll get are, there's 2 chords. Because there's 2 lines. Is the red one a chord?
No.
But it touches the circle.
Too bad.
Oh, just too bad. So I want you to recognize right now that when you state something as a chord, it better start on the circle and end on a circle. It better not start on the circle and end somewhere else. So right there, that is not a chord. Don't be the one that messes this up. All right, that's why I'm specifically putting that out. I'm putting that picture up there. So if you're one of those people that gets sloppy with notations, maybe have that picture up there. If you're someone that just like locks in, like I know what a chord is, I'll be good. You don't need to draw it. But just make sure you know what a chord is and what a chord is not. All right, the next thing we're going to talk about is a radius. Who's seen a radius before? Yeah, we should have all seen radius and diameter. So these are old terms. A radius, plural, radii, is a segment with endpoints at the center and on the circle. So a radius is just anything that starts in the center and ends on the circle. It is basically our compass. All right, it's what was basically used to make our circle. The next one is a diameter. A diameter is really 2 radii put together all the way across. And so a diameter is a chord because it starts and ends on the circle, but it's a very specific chord that cuts our circle right through the middle. So it passes through the center of the circle. So diameter, not only is it a chord, it's also 2 radii. All right, put together. That leads us to these notations. I'm not too worried about this right now, but basically our radius is half our diameter, where our diameter is 2 radii. That's all this is saying right now. Radius is half the diameter. Diameter is 2 times the radius. Any of those words blow anyone's minds? Like circle, the, from. No, we're good? Okay. Now let's talk about circle pairs real quick. A circle is congruent to another circle if their radii are congruent. So as soon as I get this measure is the same as this measure, or this measure, or this measure, those two things are congruent. They have to be. It's kind of like if you take your compass and you open up to a certain length and you spin it around and you leave it that length and you spin around, are those circles going to be the exact same shape and size?
Yes.
Yeah. Also, awesome thing, we don't need to prove that circles are similar, because guess what? All circles are similar. Because how many degrees are in a circle? That is my major arc. Alright, now I can't label it AB, because my minor arc is already labeled AB. So with a major arc, we use 3 letters. We have to use 3 letters to label a major arc. That's why we have that extra point here. So my major arc is going to be labeled A, D, B. So 3 letters indicate that I have a major arc. A, D, B. The cool thing about a major arc is all you need to do is to figure out the degrees of this one is just subtract what you're missing. Alright, this is 30 degrees. 360 minus those 30 degrees. So this major arc is going to be 330. Oop, that's 330 degrees. So all you need to know is the central arc, and you know everything else. Alright, so that's a major arc. Semicircle. Semicircle is just half a circle, right? It's an arc with endpoints that lie on the diameter. So if I have a circle, and I have a diameter, my semicircle, let's go ahead and label it. Our semicircle is just that bottom half. So our semicircle is going to be the arc A, B, C, and we still use 3 letters. We still use 3 letters for a semicircle. So the only one that uses 2 letters is a minor arc. So anytime you see 2 letters, you should be looking for a small angle. If you see 3 letters, you should be looking for either a semicircle that has a diameter. Is a diameter a chord? Yeah. A start and end point. Yes, it is. Okay. So we're almost through. The next one is we have an inscribed angle. Now I want to put a note on the so an inscribed angle is an angle that has a vertex on one side and it contains 2 chords. So it starts on one side of the circle and extends to make a chord, and it extends to make a chord. I'm going to tell you right now, we don't normally draw these lines going out here past the circle. We end at where I put those dots. So most of the time this stuff is just gone. So most of the time you're just going to see this as your inscribed angle. I just want to do that because its intercepted arc is an arc with endpoints on the sides of the inscribed angle and lies in the interior of the inscribed angle. So this would be our inscribed arc right here. And it's going to be important tomorrow because it's this would be the big arc, but it has something to do with this degree.
Oh.
It won't be the same like before. We're going to get into that tomorrow. It's actually half. Alright, this is going to be half of this size. But we'll talk more about that tomorrow.
So the intercepted arc is the one, but the red one.
Yeah, the red one. Intercepted arc is where it hits there. It's kind of like, it's a minor angle that we created. Most of the time we'll just call it a minor angle. But if you say intercepted arc, at least you know it came from an inscribed angle. So real quick, the difference. Central angle starts in the center. Inscribed starts on the actual circle. This one uses chords to make it. This one uses radii to make it. Two radii make a central angle, where two chords that meet at the same point are going to make an inscribed angle. All right, last stuff we have to talk about is tangent. A tangent line is just a line that intersects the circle at one point. All right? I said line, right? Did I say segment? Did I say ray? No, I did not. So if you ever are tricked and I say, is that a tangent line? Well, it only hits once. No, it's not, because technically this continues on and would hit again. So this right here, what I drew right here, is not tangent. And the point where it actually collides with the circle is called our point of tangency. That is our point of tangency. So line AB is tangent to circle C at point A. So technically, our tangent lines are always going to be outside of our circle. Okay, they're always going to go kind of around. So I could draw a tangent line here, I could draw it anywhere around this circle, but I can't go inside the circle. So a tangent line is not going to go inside of our circle. All right, there's 4 different types of tangency when we have 2 circles. We have what's called external tangent. That's where you have 2 circles that are butted up against each other and touch at one point. That line going right through them only touches at that point too. So that is called an externally tangent to those circles. We have internal tangent. That's where we have 2 circles, one inside the other. And where they hit, if we draw a line through that, that's called internally tangent. I can always picture that because one circle is inside the other circle. A line that is tangent to 2 circles is called a common tangent. All right, we can have an external and internal common tangent. They are external, so these 2 circles do not touch. This line hits each circle once and doesn't pass through basically what I picture as the center of these 2 circles. I call this kind of that center. So that's why it's external. Would this be external?
No. Oh, yeah.
Yeah, if it meets all the requirements. So even this would be, well, if it would hit it, it's tough to hit both. That would be external too, as long as it doesn't pass kind of this midline. On the other side, if these 2 circles do not touch, and this line actually passes through that midline, it is called internal. It's called internal. These are important tangent lines because if we look here, this actually creates a 90-degree angle. If I know this measure, I actually can find this measure. If I know this measure, I can actually do something with this measure. So it's important to recognize tangent lines. Tangent lines are going to be important for a while. All right? It's a key thing. We won't get into it. We just have to know what they're called right now. All right. The last thing we're going to do is just a cheat sheet. I just want a sheet that you don't have to look through a whole bunch of definitions, where as long as you know basically your definitions, you can look at the sheet and go, oh, that's what a radius is. Okay? So some of these I'll put notes on, other ones I will not. A radius is just something that starts in the center and goes out. And a radius can be anywhere we want it. All right? It could be spokes on there. It could just be one. We could have 4 of them. A chord just has a starting and end point on the circle, so that's a chord. Because we start and we stop. This is a chord. Because we start and we stop. This could be a chord going all the way across. And I believe I just put, I thought I put stuff on this one. I think I just put chord intersects the circle twice. Yeah, intersects 2 points on the circle. Intersects our circle twice. Diameter is a chord. So it's still a chord, but it that divides our circle in half. So it's a chord that divides our circle in half. So I just put in half. You could put whatever notes you want on there. That's why I left that whole box if you want to put other notes if you weren't quite sure what a diameter was. All right, central angle. That's the guy that starts in the middle and is constructed using two radii. So this is a radius and the other one is a radius as well. So two radii make a central angle. An inscribed angle, on the other hand, starts on the circle and is constructed with two chords. So those are chords. Our major arc is one that's bigger than 180. So let's go ahead and use an inscribed circle to create it. I want to go on this side. So if I use an inscribed angle, like this, let's call it A, B, C. My major arc would be the one that's bigger than 180. So it'd be that big guy there. So that's my major arc. And I'd label that as A, B, C. And we use 3 letters. Yeah?
If there was another point, like within that arc, would you not need to, like, say the letter?
If there was another, oh, if
Like
there's
in-
4?
Yeah.
You just need 3.
Okay.
You just need 3. So if I could have, I could have C, D, E, F, G, H, I, J, K, L. I still just have to pick 3 of them. We picked the starting and end point and one other point. So we just need 3. And the whole reason we did do that is so we can know which one's the minor. Because if I draw this exact same drawing for my minor arc, well, close to it, I'm sure it won't be exact, but we can draw it close. Call this A, B, C. Our minor arc is the one that's less than 180. And the good thing is with minor arc, we just need 2 letters. Ooh, that looks like a tilde. There we go, 2 letters. So major 3, minor 2. Semicircle is created with a diameter and just cuts the circle in half. It's just half a circle. That's a semicircle. Tangent line is a full line that touches a circle once. So it touches the circle once. Let's call this A. Let's use the same colors. Let's just call this line A, B. So AB is tangent to that circle. And the point of tangency is right here. That's our point of tangency. All right, when we have tangent circles, we really have what I like to put into 2 different camps. We have external and internal. External tangency are when I have 2 circles that are kind of butted against each other. I bet you I can't do the other one. Oh, I can. All right. And we just have a line going right through between them. Our point of tangency, it just hits each circle once. The other external one is when they're not even touching. If we just have 2 circles just out in space, I can draw a line that hits both of them like that. That is our external with 2 circles. And it could be on top as well. The other one is internal. Internal is if I have a circle, and we have another circle that's doop, 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 doop. And we have another circle. Oh, it's going to work perfectly. Another circle inside that circle. And our point of tangency, it just hits each circle once. And finally, if we have 2 circles that aren't touching, and I run like a line that looks kind of like this, and it touches each circle once, that is also called internal. And what I like to think, I always picture if it's external or internal. Remember, it won't pass this midline if it's external. If it's internal, it'll cut that midline right down the middle. All right, your homework is just basically applying all those words to a drawing. So for example, if I have to draw circle A with chord BC and tangent CE, what we're going to do is we're going to first draw a circle. And to name it A, I need to put a point and put A on it. All right, now I have to draw a chord BC. It doesn't say where to draw it, so you can draw it wherever you want to. You could pick any line that hits twice. And we just have to say, well, one of these is B, and the other one is C. And then it also says it's tangent CE. So to draw tangent CE, well, that must mean that it's tangent at point C. And we just have to pick another point and call it E. And that meets all the requirements of that. So all of our drawings aren't going to look the same. That's why there's no answer key to this one. You just have to make sure it meets all those definitions. And you don't reuse a letter. Okay? So make sure you don't all of a sudden go, oh, it's tangent at C. Okay, well, I'll draw a thing that's right here and call it CE. Do not do that because that's reusing a letter. Do not reuse letters. If you already have C down, you have to use it in that drawing. All right? Go ahead and get started. Most of you will probably, if not get completely finished, almost completely finished.